And looks like we are live. Hello,
Okay,
everyone.
right.
Welcome.
Hello, hello. Can
Hello.
you hear us? Can you see us? Please give us a thumb up in the chat. Just audio check, and if it's okay, we will start.
Can you hear us? Hello. Hi, Animesh. Hi, Bridget. Hello.
Hello,
Hi,
hello.
Shwarya. Yes. Okay. I think we are good.
Okay, right. Yeah. So thank you for the audio check, Daigo. We never know, even if we host, it's not easy to know. Okay, so welcome everyone for this 2 hours workshop starting a 4 weeks bootcamp to make you pretty skillful in NoSQL and Apache Cassandra. This week is really introduction to NoSQL and Apache Cassandra, and you will see what's coming in the next week. So this content is provided to you by the DataStax Developer Advocate crew that you can see on screen. Some of us are with you in the chat right now answering your question. And Stefano and me are on screen. So let us introduce ourselves. I will go first, slide first. Sorry, Stefano.
Yes.
So I'm leading this team of developer advocates. I do have a Java background. I created an open source framework, and I do everything I can to bring some awareness around the Cassandra technology and more. And I'm also writing the software development kit to use a tool we will use today for the hands-on practice called Astra. You do have my coordinates. Don't hesitate to invite me on LinkedIn. Would be happy to have you in my network. And with me, Stefano.
Yes. Hi, everyone. I'm Stefano. Yeah, I am a developer advocate at DataStax with Cedric and with all the other guys you've seen in the previous slide. Yes, for me, the same. So please feel free to connect with me. That would be great. I am mostly a developer with a tinge of a data architect. I like and I know Apache Cassandra. My background is in Python and JavaScript. And I have a background in computational physics, which led me to get interested and love distributed systems, in particular Cassandra, which is a wonderful technology. And I love to teach. I've been a teacher in schools, in universities, and whatnot. I'm also a scuba diver teacher, by the way. And I like to communicate, so here I am. Hi, Alex. I see Alex in the chat. Nice to see you there.
Alex with us in the chat. Hello, Alex. So today, 6 parts, introducing how the bootcamp and this workshop works, doing theory introduction to NoSQL database, what are there, go to introduction to Cassandra, what is the CAP theorem, more about Cassandra, table and partition. You will do some exercises, practice a little bit during the session and way more over the week as homework. But do not worry. I will explain you in detail what it is. So here you do have the full pictures. Everything is available for you on GitHub as well. Again, we will give you all the links. So I keep talking about 4 weeks bootcamp. So quickly, it's the first week, beginning of the year. So we wanted to give you some content to learn more about Cassandra and be able to take the certification after a month of training, some hands-on session every week, and some personal work to do after the session. So week 1 today is the second session. We had the same content yesterday at the North America time zone friendly. So this session is more dedicated for people in EMEA and APAC. So 2-hour live session and covering introduction to NoSQL and Cassandra. Okay, next week, focus into Cassandra data model, feature for real application, real world application, full stack application, as you can see. Week 3, we start coding. We take the drivers and do some exercises with Java, Python, and JavaScript to interact with this database, because now, after 2 weeks, you know what it does, you know how to use it. And week 4, on top of these small sample code you did week 3, we will create real backend, real full stack backend using Express, Django, and Spring Boot. Again, Java, JavaScript, Python. Okay, so a lot of learning, teaching, and coding. So I hope you will enjoy the ride. We are together for 1 month, even if each session is standalone. So if you want to tell your friend, now is a good time to start embracing this session. After the 4 weeks, we will give you some voucher to be able to pass the certification for free. Okay, so how does it work? Pretty easy. Just stay with us for the 2 hours for the live stream workshop, Wednesday or Thursday. Okay, we are live on YouTube and also on Twitch. We answer your question live on YouTube. You will see that, yes, it's a first class. We answer your question on YouTube. And also we have a Discord room, because when the stream is ended, you may want to ask question, and we will be on Discord all week long to answer your question. It's an interactive session. Okay, it's just not 2 heads talking on screen. We will do some practice. We will also play some games, and first game will be pretty soon. We will answer question you live, and with your phone you can give your answer, and it will show up on screen. And we use something called Menti to do that. So very soon we will ask you to open a new tab or use your phone and go to a website to play with us. That's the live session. So to complete the workshop labs, we will do some exercises together. Part of the exercises will be demo, just to stay in the 2 hours. And as your personal work, you will have to finish those labs. First step. So to do the labs, you won't have anything to install. We do have the database Cassandra ready for you. We do have an IDE. Of course, you can still use your own IDE, on your local machine, VS Code, Eclipse, IntelliJ, whatever. But for the live, we will, invite you to use Gitpod IDE, because there is nothing to install, and it's hard for us to debug you during the live session. You will see also some Katacoda full-fledged environment to learn new part of the database. All the materials, exercises, courses, code, slides, all are on GitHub, and we will give you the link. By the way, you see we have a bot on the YouTube chat right now. So if you do bang !GitHub, you get the link of GitHub. !Astra, you get the link for Astra. Menti, you get the how to connect Menti to play the game with us. So then, learning materials, okay, to be ready for the certification, 2 hours is not enough. We will give you the key, but then you will need to take a free online courses over the week, just to get more in deep with the technology. Okay, again, nothing to install. We have some dedicated website, Academy, DataStax/dev, or still GitHub. Okay. And week 4, after each week, like every bootcamp or course you have done in the past, we would like to check that you do have the knowledge, and we will give you a Google form to validate your week. Okay, you don't need to be especially on time. You can catch up later, but better to stay on time. When you complete the week, we grant you a badge. As you can see here, badges, 1 badges for each week, and a big badges kind of certificate at the end of the bootcamp. Okay, but here the target is to build you some skills, and also make you skillful to pass the certification in the end. That are our 2 goals. Okay. And with that, I think we can start the interactivity, just to try for the first time a Menti. Yes. So now what I will ask you is to to open a new tab in your browser, go to menti.com, and use the code that we will give you.
Yes, please. So let me ask Nightbot to give us the code and switch to my screen. Here.
Yes.
And there we go. Okay, so we are about to ask you to join Menti, so you can do that from your phone or just another tab in your browser. And what is Menti is basically a platform to ask you questions interactively. I see someone is already joining, so welcome, welcome. You go to menti.com and use the code that you've seen here in the chat, and you see also on my screen. You see there is also a way to join it by scanning a QR code. So we are about to ask you some questions. Oh, wait, I'm hiding the number, so I'll be temporarily invisible for you to see the code. But you can still hear my voice around. So, you know, we want to get to know better. So we want to know what kind of developers you are and what are your interests. So we will be asking you a few questions to know you better. So let me go back to the Menti screen in the meantime. And this is also a way to get you connected with Menti, because please, when this initial survey is over, please keep the connection open to Menti, because by the end of today's session, there will be a quiz with questions for you. And for those questions, if you answer fast, you will have a chance to win some nice prizes, some nice swag. So please, I see 30 something already joined Menti. So
yeah, and you know what, Stefano, we are almost 100 on YouTube right now.
So we wait a little more. So please jump on menti.com, use the code you see, and in a while we will start. So
yeah, it's the first time maybe you deals with Menti, so yeah, let's give 1 minute for people to go. So
platform.
Again, the code is always at the very top of the screen, you know, and I keep posting the code as well in the chat.
Yes, so let's give another minute or so. So, okay, so we are now about to ask you a few questions just to know you better, but later on, please don't forget that you will have a chance to win some prizes by answering questions about what you learned today.
Yep, exactly.
So we passed the 51 mark, so nice. Maybe we can start.
Okay, let's do it.
Okay. By the way, please do not answer in the YouTube chat, because those would be wasted answers, unfortunately. And that's even more important later when we get to the quiz.
Yeah, you want your answer to be on screen. So yeah, take the time, open new menti.com new tab, enter the code, and you will see something that you answer will be on screen with us live.
Okay, so let's see, we are about 60, so we can start. And before starting with the quiz, let's ask you a few questions to get to know you better. First, where are you watching us from? Where are you connecting from? You don't need to be extremely accurate. We just want to have an idea. So, hello, Australia, India.
This session is Africa. Meant to be in APAC, and see, it seems to work.
Yes, it seems so. Even though I see someone from the US as well. Hello. Europe, India, Indian Ocean, Australia. Is that Portugal, France, Germany maybe, Russia, Sweden?
Oh, look at that. Turkey. It's so distributed, like cool. The database we will cover today.
Yes, that would make for a great distributed
and
database.
more people in India in the chat. So, you know, please use Menti. Oh, look at that, in the middle of Asia. I will not even try to give the name of the country here. There are so many in this small region.
But it's great over the world. Okay.
Nice. Okay.
Malaysia,
so
I see. Malaysia.
Oh, wow.
Great. Okay. So let's move on. Next question. have you been to any of our workshops before this one?
And we're asking the question because we are live every week for almost 2 years, twice a week, most of the time. So we have, I don't know, 100 workshop or something, and it's always the same format. You have 2 speakers, and it's all interactive. We are covering a lot of topic, but you can have a look in our YouTube channel to go back in time and see everything we cover. But all the main Java, JavaScript, Python frameworks, architecture, a lot. But do not talk too much about that. You will learn more in these 4 weeks to come.
Oh yeah, definitely. So I see many of you are newcomers. Welcome. It's great to see you. And yeah, so we hope you will like it. And next question. Do you have experience with NoSQL databases? Never used it? Some experience, a lot of experience, or are you really a master of NoSQL? Oh, I see we have a master. Congratulations. But you will learn something anyway, because there is always something to learn. But yeah, overall, I see most of you have little to no experience with NoSQL databases. That's perfectly fine. Because
exactly what we expect for this session. Yeah. We are going back to the beginning.
Yeah, we will start from the beginning, so no particular previous knowledge required, which is great. So welcome everyone. And I see most answers I think have come in. So let's move to the next question, which is no question. So I'm sorry. That was the end of it.
So
okay.
3 small questions indeed in the beginning. Yeah. Just for everybody to get used into this Menti. Also for us to know if you know where are you located and if we are at the good time zone and to improve over time.
Okay. So again, I will not close this Menti, and you should do the same. So keep it open, because later it will be very useful if you want to play in the quiz and maybe win some prizes. And with that, thank you for the answers. And let me give it back to you, Cedric. Is that okay? Ready?
I'm ready. I think we are 18 minutes in. And we have covered all the housekeeping. You play a little game, so you are all set for this session now. Time for content, right?
Time to start, yes. And with that, let's start.
Yeah, let's see. Yep, okay, all right, let's go. So intro to NoSQL. Here we go. Why NoSQL was invented? Okay. You can ask the question because relational database like MySQL, Postgre, Oracle dominated the database market for decades. So why did it change? Okay, why did it change? What do you see some database like Cassandra, MongoDB, Redis, Elastic? Why more and more NoSQL databases? Let's go into it. And even going into it, I would like just to mention NoSQL means not only SQL. So it's not one against the other, because I know we will get the question. Okay, so let's dig into what is NoSQL. Well, the issue with relational database where it was not ready to cope with the new volume of data. They have been designed to be installed on a single machine, single server, and it's not easy to scale. So at some point, you do have too many data to be stored on the single machine. And also, if you have terabyte of data, a relational database tends to be slower and slower. So you need to have to do something about volume. Second is velocity. Okay, so relational database, RDBMS, to make it short, can only do, I don't know, a couple of 1,000 transactions per second. That's the hard limit. When I used to administrate an Oracle database, we told that above 4,000 transactions per second, it was a bit hard, and it was a lot of customization to make it work. But in the reality right now, we need some database that can do some millions of read and writes per second, right? So By default, RDBMS are not good enough. Third is the variety. We used to put only tables and joins in the database, but now you want to put many types of data: schemaless, document, graph, relational entities, some raw object. Big data also is all about unformalized data with no schema, stuff like that. So volume, variety, velocity, this is what we call the 3V, are the reason why you kind of limited with RDBMS. Also, if you look at the volume of data that will come over the year to come, see 2022, 3, 4, 5, we will go to 175 zettabyte of data. I think that's, zeta is like 10 to the power 21. That's just crazy amount of data to store now. And of course, we will need some tools that can cope with so many data, so much data. Few terms: OLTP, OLAP. OLTP means online transaction processing. It is everything that is real time. I read and write in real time, simple queries. This is one way to use SQL and request, right? OLAP means online analytical processing. Those are used more in data warehouse. The query could take minutes. The use case are do some aggregation, computation at the end of the day to know everything what happened. It does not to be super fast. It's more computation intensive than read-write. And so when people design relational database RDBMS, they have to make some trade-off to be good in both OLTP and OLAP. Okay, so OLTP, traditional 3 normal form data model. OLAP is more data warehouse, what we call, and more like Snowflake data model, or data mart, or more about denormalization. And because it's a trade-off, you cannot go strong on OLTP, strong on OLAP. And so some NoSQL database are here to help in one case or another. So relational database on the left part, any database that supports SQL. So relational database, SQL, RDBMS, all the same. Okay. And not only SQL cover a wide range of technology, variety, velocity. So document database, maybe this is the one you have heard about. MongoDB, Elastic, you want to save JSON, okay? Key value, Redis, Dynamo, Memcache, everything that is distributed cache, okay? Tabular database, this is the one we will cover today with Cassandra and over the weeks to come. This is the one we will focus on, tabular database, okay? Ledger database, so more like event storming, append only, so QLDB, KSQLDB, append only, more used to keep the track of everything that happened on the database. You only add mutation, and at any point of time you can see everything that happened with your record. Time series, huge time series database, Influx, OpenTSDB, Prometheus, and graph database like Neo4j, Graph, DataStax, Graph. If you have your dataset highly connected, Titan as well. So we won't go into too many details of these 6 flavors of database. On this channel, we have some workshop, 2 hours, 3 hours long, to have some hands-on with each one of those. But for the bootcamp, okay, now we will focus on tabular database. And I would like to know, it's not one against the other. There is no one which is better than the other. It's always based on your use case, okay? Is your use case read intensive, write intensive? What is your data format? What is the way you would like to query the data? How much volume do you want to keep? Those are the questions you need to ask, and you will see, okay, maybe this database or the other is better. And when you pick the flavor of database, let's say tabular database, okay, yeah, then only then you can do some analysis to see, hey, is Cassandra based big table better for my company? Start doing some POC, POV. But picking one flavor of NoSQL database against another should be more based on your use case and constraint. You should know which one. Okay, so now let's move to Cassandra, tabular databases, okay? And Cassandra is used by company, by the GAFAM, okay, by huge company, and especially Netflix and Apple. So we had a chance to have the tech lead of Netflix on this very YouTube channel that shares some numbers with us, stating that 98% of streaming data is stored in Apache Cassandra at Netflix. Netflix have some active cluster. So a cluster is a database installation with multiple machines. Okay, so Netflix have some cluster with thousands of nodes. Okay, and a whopping 30 million operations per second. That's just crazy. 500 terabytes and a lot of CPUs. That's just crazy. And at Apple, look at that, 160K Apache Cassandra instances, and it was in 2018. So 100 petabyte store and same, 7 million operations per second. So the biggest strength of Cassandra, and you will see that, is that it scales as much as you need, as much as you want. And Apple is not even the biggest Cassandra user on the planet. For a long time, we think it was the case, but now we know that we have the biggest company in China that are even bigger than that, And you know who I'm talking about. Always the four same in China. Okay, so Apache Cassandra is a NoSQL distributed, decentralized database. It's big data ready. It's designed for read and write performance, especially write performance. It has in what we call linear scalability. If you need more capacity throughput at node, high availability, you will see you have multiple machines in your cluster. You can lose any machine. It's not a big deal. The system is still available. There is no failure. And if the node come back, it's self-healing. Geographical distribution, performance agnostic, vendor independent, but I do have a slide for each one of those. By the way, we told you the slides are on the GitHub repo, so you can keep them. Okay, so what you see on the right part is how we represent an installation of Cassandra living on multiple machines. Okay, this is what we call a ring or a data center, and each dot is a server, an installation. Okay. And so when you install Cassandra on multiple machines. I told you that. And each machine, each server is in charge of a subpart of the data. This is what we call partitioning. So partitioning over distributed architecture make the database capable to handle any size. Okay. So on one node, rule of thumb in my head, 1 terabyte of data per node. So if you need more capacity, simply add new node. Second is masterless. So here there is no master, no slave. You can lose any of the node if all the nodes are even, and you can read and write from every node. Okay, we will come back more into these consistency stuff later. But what you need to understand is every node is equal in Cassandra and could do read and write, and no master. Okay, we told you about linear liability. If you don't believe us, that's a benchmark from Netflix and see how it behaves. By the way, Cassandra is Apache Cassandra, Apache 2 license. It's free and open source, okay? So you see, I'm pretty advocating for Cassandra. It's super strong, but hey, it's free, okay? In a Cassandra cluster, you can have one ring. You can also have multiple rings. You install ring on different location. It's geographically distributed. You can read and write from anywhere, and the data will be replicated for you. So replication, decentralization are done at Cassandra level. There is no single point of failure. And you, in your application, the driver you use is super intelligent. If you send some data through the driver will know where to go and where to put the data. And we will explain you more how the data is distributed among these nodes or among these machines. Okay, you might ask the question, hey, where do I know my data live? I will explain that to you in a couple of minutes. Okay, that's all for now. It's really the concept and the architecture overall. With so many machines, so many machines, sometimes it could be hard to manage, right? It should be automated as much as possible. But fortunately, Cassandra helps you with this scaling. You add nodes, and Cassandra will redistribute the data for you. And if node is down, the system is still working because your data live on multiple machine, multiple node, data is replicated. Okay, and if the node is back, the system will self-heal automatically. That's cool, right? Probably cooler than this creepy and spooky GIF. Okay, so if you install a Cassandra cluster, trademark deploy on multiple data center, multiple rings, that's pretty convenient, for instance, legal region. If you're living in Germany, you like your data to live in Germany, and same for French, China, and a lot of laws and regulation ask you to have your data locally. At the same time, you can have some public data available across the world. They are all alive. It's active architecture. There is no, primary, secondary. No. Every node, every DC is active anytime. What you can have in geographic distribution, you can do the same with technical distribution. Why not having a ring on each cloud provider and make them part of the same cluster? Totally doable. Now we are technical, not marketing. It's not magic. You still need to open the network route in between the cloud providers. There are some dedicated companies that do that, like Aviatrix, for instance. You can also open some MPLS lines in between your cloud. But hey, technically speaking, Cassandra could be a platform agnostic, single technology available across the cloud providers. Okay, so Cassandra is not bound to any platform, no lock-in. Pretty cool, right? So no lock-in, scale, distributed, replicated, pretty cool. And Cassandra is part of the Apache Foundation. And so there is no chance that Cassandra change the license, anytime soon, making more closed source or something like that. It's a non-profit open source foundation, and it's super active. We have Cassandra 4.0 has been released last year. And since then, we have seen some great energy in the community. Great stuff are coming in the project right now. Okay, hope it looks cool, and it was only 50 minutes of, hey, all the promise of Cassandra. How does it work? A lot of promise, and do not really read the chat right now, but Probably sure you have your head full of questions. So let's dig into how does Cassandra works. Okay, so first, all servers are created equals. Cassandra only book. Love this quote, Alex. Love this quote. Okay, so what masterless mean? In previous, relational database works like that. Some NoSQL database work like that. They do have a leader or master and follower called slave. The way it works, you can only write on the master or leader, and it's a single point of failure. And you write on the single place just to be sure about the consistency, and then the data is replicated on the follower. And with this kind of architecture, traditional architecture, you immediately realize that it could be good for read. You can add as many followers as you need to be able to read a lot, to be web scale, as some company like to say. But for write, it's not good because you do have a single point of failure, and this is your leader. And we told you that because with Cassandra, every node is equal. There is no point of failure, okay? You can read and write from any node. It's a peer-to-peer architecture. And you can contact any node. Okay, first important things to remind you. Peer-to-peer, no master. Just saying, could be useful for the question and game at the end. Second, data is replicated. So this is your data center. This is your ring. And I told you, okay, the same row, the same data is available on multiple nodes. It's replicated. It's called the replication factor. And the idea is if you lose any of the node, not a big deal because the same data is still available somewhere else. That's the point. So when you create a database and something called a key space, we will see that later what it is, you design how many times does your data is copied. So here it's just a sample. We create a key space in a Cassandra with two data center, two rings, if you want. The first rings is called US West 1. In there, I will have a replication factor of 3. And on the second one, I will have a replication factor of 5. It's by data center, okay? Some data center would like to have a higher replication rate because maybe they are hostile and you do have more chance to lose any node. But recommended number is 3. Sometimes you go up to 5, but it does not really make sense to go above 5 because then you have a lot of time the same data that took in space on disk. Okay, if the replication factor is 1, then your data lives on a single node here. If now I update to 2, the data, same data is on 2 nodes. Okay, you got the ID. And 3, the same data is on 3 nodes. And so if I lose a node, no big deal. I still have 2 and I can read from them. And I told you the driver, the way you connect to the database is clever enough to, if I try one node and it's not working, at the driver level, it will retry and contact a second node with the same data. Your application won't even notice that you had a miss. Data is distributed. So this one is very, very important. Again, now I put my data center or rings, always using two terms, on the left part. In Cassandra, you will store tables. In this table, you will have a very, very important column or set of columns. Could be a set of columns. And it's called the partition key. Based on the value in the partition key, the data will be stored on different nodes like that. Okay, so even a single small table like that will be distributed among all the nodes like that, based on the value of the partition key. Each node will have multiple partition, of course, but all the rows with the same partition key will be stored at the same node. You store together what you want to retrieve together. Now, a node could have multiple partition. Here you see a single row partition and a second single row partition. Okay, with this slide, you can say, oh, wow, so if I do select star from my table, it's not a good idea, even if the table is small, because Cassandra needs to fetch some pieces of the data on every single node. This is what we call a full scan cluster, and you really want to avoid that. So data is distributed. Maybe you asked the question how the data is distributed. So now again, when you create, it's not again, first time we see this statement. When you create a table now, you will design what is your primary key. Primary key is there to ensure your unicity. And inside the primary key, you get the partition key. So partition key is only a part of your primary key, and partition key alone does not ensure unicity of your record. You can see that the same multiple records have the same partition key. Okay. Why partitioning? I mean, you say, hey, why should I distribute my data among multiple nodes? Well, I told you already, with so many data, it will take forever to screen data on a single machine. It will take super long, and eventually you won't get any space left or any big enough hard disk drive to store that many data, and that's pretty risky as well. So as you can see, Netflix, Apple make the choice to have hundreds and hundreds of small server. It behave better, and if you have heard about Kubernetes a bit, a way to deploy some software nowadays, it's the same logic, working with small systems, small pods. And if you want to add power to your system, you scale out, you add more nodes, and you don't add capacity to your machine. Okay. So how the data is distributed? I show you this schema and say, hey, okay, but how do I know that USA should be on the node at the top? How do I know that FR should be on the second node, and so forth and so on? Well, we do have something called a partitioner, and it's using a free algorithm called Murmur3, but you can change the algorithm if you want. So it will hash the value of the partition key. It will give you a number, an integer, between 1 and 2 to the power 64. And this number is called a token. Okay, so each time you want to write something in Cassandra, Cassandra will take the value of the partition key, will hash the value and get an integer. And then each node is in charge of a range of the token. It's like doing a modulo. So I do have the integer, and now I know the range, and I can contact the proper node and save my data in the proper node. So this is why we could represent a Cassandra node with its token range. So here, instead of going from 1 to the power 2 to the power 64, it's too big. For the slides to come, let's pretend that on a table you can have 100 record, and I will do my token range between 1 and 100. So if I do have 4 nodes, it's easy, 25 on each node, right? As just stated. If I now add a new node, scaling out, add a new node to my machine, then the token range are recalculated. Okay, And now this is the new allocation of my token range. So Cassandra will do the work for you live with no downtime. So if you can see, the first node now is in only charge of 1 to 20. So anything from 20 to 25 should be moved to the second. So there will be streaming in between node 1 and node 2 to copy the part of the data that need to be copied. But the data from 20 to 25 on node 1 will be decommissioned, deleted only when all the replication are done. And so as a consequence, there is absolutely no downtime. And this is why you can scale out with no downtime. Or you can scale in, or you can scale down if you want. Now, if scale down may be better than scale in. If you scale down, now you scale down to 3 nodes, and the token range again are redistributed. Scale down could be tricky. You need to be sure that your smaller number of nodes can handle the volume. I told you, in between 1 and 2 terabytes of data per node. So scale down could be, it's not something you do very, very frequently, but totally doable with Cassandra. Data is distributed. Now, if on top of distribution, I add the replication factor, okay, so 4 nodes, this is how the data is distributed, okay? If I had the replication factor, now that means the same node is in charge of 2 token range, 1 to 24, eventually as well 26 to 50. It's of course, it's not consecutive token range. Here it's just to be as simple as possible. But now you need to understand that if you increase the replication factor, then the same token range, like 2650, is available on 2 nodes. So 26 to 50 is available on node 1 and also on node 2. And if I want to put some colors in the cluster, this is what it looks like, okay? So if this guy is in charge of 0 to 16, 17 to 20 to 33, 6 node DC, the data in this token range is available here, here, and here for the replication factor 3. Okay, so hope it's clear. Data is replicated, data is distributed this way. So now, what if you want to save data there? How does it work? The data come. The partition key is USA. USA is hashed using the Murmur3 algorithm. You get an integer. This integer is what we call the token. Here, token is 59. You can contact any of the node, even if the node is not in charge of 59. Look at that. This node in blue has nothing to do with the 59. 59 is not part of the token range handled by this node. Not a big deal. The node will simply send the data to the 3 replica, the one in charge of this data. Boom. Now your data will be in the proper node. And so for this request, node here called 17 is what we call the coordinator node. It's not a master, it's not a leader, it's a coordinator node, and the coordinator node will change for every single request you make. It's a coordinator node for the request, and that's it. Okay, so each Cassandra node and the Cassandra drivers is aware of the token distribution. So what you just seen before, like somebody writing node writing some data to a node not in charge of 59 could not really happen in reality. The driver is clever, so he will send the data to one of the replica in charge of the data, just for the request to be as fast as possible. Data is distributed globally. I've seen that. We have seen that in the slide just before. So geography and hybrid cloud. Okay. Woohoo! Almost done with the theory. After chapter 4, you could really start, creating your first instance and doing so first queries against that instance. So far so good. Stefano, do we have any leftover question, or are we good?
Well, there are very interesting questions in the chat about how replication works, what are tokens, but I think Alex and I are doing a great job at answering them.
Okay.
There has been a question that will probably be answered by what you are going to speak next, namely whether replication will cause any redundancy during access. And I think you will soon speak of consistency levels, and that will be a great answer. So go ahead.
Okay, nice. Yeah, great question, by the way. Yeah, thank you for the question. It's all about interactivity. Okay, what is the biggest problem of replication? Or you might already know, right? If the same data live on two nodes, how do we know that they are already in sync? How can you be sure that one data is not in advance? It's not in the future and the other in the past. Okay. You could have potential inconsistency. So the new value here, let's say, is 13, and the 3 replica at the beginning of that are at 12. You want to update the value exactly as we have shown before. Pushing the new value to the 3 node. And during that operation, one node was not available. So what will happen? 2 nodes will be updated, 13, 12, because it has not been updated, and now 13. And you do have some inconsistency between the 3 nodes. That could happen, okay? So how do we handle those use cases? Well, you do that by using what we'll call a consistency level. So replication factor 3, we have seen that, send the data. If a node is down, exactly as we have shown before, well, the value is saved at the coordinator level, something called int. The full mechanism is called inted handoff. So as right now, we do have an inconsistency because node in orange did not get the new value. And so the coordinator will save the data locally for 3 hours by default. And when the node goes back online, you restart the node, or the network is back, the database is self-healing because node 17 noticed that this guy is online and will push the data there. Okay. Now let's go to CAP theorem. So C, A, and P means for 3 features in distributed system. It's very important to understand that what I will tell you is for distributed system having multiple servers. A for availability, okay, you can access your data. C for consistency, multiple machines having the same data are in sync, are consistent. And partition tolerance are issues that could happen in your network. You lose in your system, you lose the network in between the node, you lose, the node cannot communicate one to each other. So if the nodes are not able to communicate to each other, how do you choose consistency availability? Well, this is what we will see. Availability, basically uptime. Okay, you ask the question, you get the answer, no downtime. Even if you lose a node, system still available. There are still nodes able to answer your request. And this is exactly how Cassandra works. You have seen just before that if you lose one of the nodes, you can still get the value because multiple replica remain and the newest value is still there somewhere. Consistency, that's the issue, right? Oh, at any point of time, the 3 replica cannot be 100% in sync. That's not a big deal. Cassandra has some way to cope with that, and we will show that in a minute. And partition tolerance, yeah, as stated here, it's the ability to survive network partitioning, okay? If your system is a master, slave, leader, follower, if, bad luck, your leader was on one side, well, on the other side, now there is no leader. So what database tends to do is elect a new leader. Then the network come back, and all of a sudden you do have 2 leaders, and this is what we call a split brain, and we need to handle that. Fortunately, with Cassandra, it's not the case, okay? So it's masterless, and there is no need for master, and so with that, you can tell what Cassandra is good at. But, keep going. The CAP theorem, also called Eric Brewer theorem, tells you that in a distributed system, you cannot have the 3 at the same time. You need to choose. If something goes wrong, partition tolerance, you need to make a choice. You push for consistency or you push for availability. If you push for consistency and want to be sure that all the nodes are always in sync, if a node is not there, well, you cannot write anymore in the database or read anymore in the database because the database will block you, because otherwise the node won't be consistent. So those are the system called CP, consistent partition tolerance. And system like Kafka, Mongo, etcd are all CP. Now you can make another choice. You can say, okay, I accept that my nodes are not all the time consistent, but I want my system to be available. And this is the choice that Cassandra has made. As you see in the slide before, the 3 replica may not be 100% consistent, but the availability is there. So this system is called AP, availability partition tolerance. So Cassandra is AP, availability and partition tolerance. But it's better than that. Cassandra is what you want Cassandra to be. When you read and write something in Cassandra, you will set something called the consistency level. You will tell how many nodes do I want to contact to get my result. And based on that, you could have one answer, the majority of the node as answer called quorum, or all the node to reply, consistency all. And based on the consistency level you choose for your request, you will be mostly AP or mostly CP. So let's see how it works. So this is all the consistency level available. I won't go too much into the details. So here, let's pick an example, to be real, to be very clear. In my cluster, I do have a replication factor of 3. The same data live on 3 nodes. Okay. And for this query, I put the consistency level to 1. So the clients connect to any of the node, not a big deal, send the data in the 3 replication factor 3, but will only wait for the first acknowledgement to say to the client, okay, your data has been saved. So this one is the fastest because it waits for single acknowledgement. But for consistency, it's not the best because you know that only one of the nodes got the latest version. It will also happen on node 2 and 3, but maybe later the client did not wait for node 2 and 3 to have been updated. Second is a quorum. Hey, you want the majority of the node to be updated. Safer, maybe a little longer, but if the majority of the node is covered, I feel better, and that's the recommended way. Okay. You can also set, hey, now I want to be safe. I want all the node to be written, get the acknowledgement of 3 nodes, and now I'm sure that everybody is aware and get the notification. Great, why not? But then with this request, you are consistent at all costs. And if you lose any of these 3 nodes, all of a sudden, well, your request will fail because the consistency all cannot be achieved. And it's not recommended in Cassandra. Okay, so maybe for very, very critical queries, you are tempted to do so. But, instead of having consistency level all and be a CP system, we can do better. It's a trap. So in the consistency level, that's really the most important slide. You can ensure what we call immediate consistency. How does it work? You will write and you will read with quorum. The formula to remember is at the top of the screen. The consistency level read plus consistency level write should be bigger than the replication factor. How does it work? Let's try to be clear. Again, as before, clients come and write the data, okay, asking for consistency level quorum. Data is sent to node 1, 2, and 3, okay? Client waits only for 2 acknowledgements. Let's say node 1 reply, node 2 reply, client is acknowledged, and client does not wait for acknowledge, wait node 3. Okay? You got it. Now, at the very same time, of course, it's always at the very same time, it's consistency. Another client, maybe we could call client 2 for the guy on the left part of the screen, come and ask for a read, and read with quorum. So read with quorum means I would like the data coming from 2 nodes, to be sure. And this time, okay, instead of picking node 1 and 2, which is the most up to date, it will be too easy, right? The read decide to pick node 1 and node 3. Oh, all of a sudden we could have an issue because now we have 2 different values to send to the client. And this is where Cassandra have a rule who say the last write always win. So only the most updated value will be sent to the client. And if you read with quorum, got the majority of the node, read with quorum, got the majority of the node, you can be sure, mathematically proven, that part of the replica, when you read, will get the latest update. And the client will get the latest value of your data. So pretty cool, right? Even if at some point of time, not all the nodes are totally in sync, you can read and write with data in sync. That's the magic of eventual and immediate consistency. Okay, it was a lot of theory. It has been about an hour. I think we should now move to a little bit at hands-on. What do you think, Stefano?
Yes, very good. So I think you have seen a lot of theory, how Cassandra works, how data is distributed. So maybe it's a good time to show you some hands to help you and to see together some hands-on parts. So for that, let me first give you again the link to the GitHub repo, asking Nightbot to give it. Let me first switch to my screen here, and there we go. There we go. Okay. So you see now in the YouTube chat, there is a link to this very GitHub repository I'm showing you now. This contains all you need to refresh what you're seeing today and to maybe dig even deeper and go to the practice part, which is required part when you are serious about learning. So
yeah.
okay.
Or if you like me, like to learn by doing.
Oh yes, well, practice is important, right? So okay, so this is the repository, and it comes with a very nice README that explains everything. So I will just show you quickly. Here you can find the slides. You find instructions on the lab to do. But now let's jump right in the practice part, and we start by creating our AstraDB instance. So what does it mean? You have seen what AstraDB is. So AstraDB is a database available in the cloud, which means managed, so you don't have to worry about maintenance and operations, and it's ready for you to use up to a very generous free tier, by the way. So you get free credit every month. Free credit every month to use it, and that's not just to play with it, but you are very much encouraged to use it for let's say real life applications. And yeah, even a small scale production application will probably fit into this limit, which means millions of reads and quite several gigabytes of storage every month for free. So to register to Astra and start creating your database, you please let me also make this here, Astra. You click on this sign in to AstraDB. Maybe you can click it in a new tab. So you should get to a screen where you can register. So that's completely free. You can register with name, email, and password, or with GitHub or Google. Please go ahead and register. Of course, I already have an account, so I will sign in with my existing account. Okay, so in the meantime, you will be registering here, and you will be asked questions such as what is your primary programming language? Just give any answer you feel like giving. And you should then get to a screen like this one, which is your AstraDB dashboard. So, by the way, all of these instructions are spelled out here in the README. So let's see, register to AstraDB, choose Start Free Now. Then you will be asked to create a new database, which, for example, you can do with this big Create Database button. Now, I'm clicking on this Create Database button, and there are a few fields to fill. Of course, any database has a name, and we encourage you to please do not be too creative, and for today, just use the name we suggest. So I'll put it in the chat. Database name, use workshops, and key space name, use Cassandra. You find them in the YouTube chat as well as in the README here. So please, here, I'm creating my database and I call it workshops. And the key space I called Cassandra. Now, we briefly mentioned that. What is a key space? A key space is a logical grouping within a database. Let's say it's a group of tables. So usually when you are writing an application, you want to keep all tables together. You probably want to group them into a single key space. So you might have a big database, and within that database, you can have several key spaces, each one taking care of a particular part of a bigger application, or even they might be related to different applications, different services, and whatnot. Now, today we just create a key space called Cassandra. Why this name? Because today's example will be about a very simplified chat application. So there will be a database hosting something such as users and posts by users. So we call the key space Cassandra. Now, please. Sorry.
Don't want to interrupt, but just a remark. Today we are using Cassandra, okay, standalone sample. For the weeks to come, we will move to the to-do application. I told you we will do code. Yes. So now week 2, 3, 4 will be all about the to-do application. But for now, it's really focusing on how to handle Cassandra and nothing else. So Cassandra is just the best for that.
Yes. So today is just to get some get your hands dirty. We don't have a real application behind this chat example, but we do have a real application about the to-do application, the to-do app. So when it will be about coding, it will be the to-do application, which is a full-fledged sample application we will work with in the next weeks. But today, just for the sake of example, let me guide you through creation of this database and key space. So workshops, Cassandra, and then you see the cool thing is you can choose any cloud provider you prefer. So there's a question about key space. Well, don't mind that too much. A key space is a group of tables. So we will create tables in this database and we just put them into a key space, let's say a bag of tables called Cassandra. Okay, you see you can choose any cloud provider you prefer. So Google Cloud, AWS, Azure. Let me go for AWS. Okay, it seems like... Okay, so let me stay on Google Cloud. For some reason I have regions that I'm not allowed to... Okay, so let me go for Google Cloud. And so you choose a cloud provider, an area, and a region, and you can then go for the Create a Database button. So let me recap that you are creating a database for today to play with, and it will be the same database you will later use probably in the next weeks, because workshops is the general name. But today we are using a key space called Cassandra. Now, you choose a cloud provider, a region within an area, and you click Create Database. Okay. Now, it will take a few minutes, let's say probably a couple of minutes, and your database is being created. You will see it here. You see now I am back to my AstraDB dashboard, and what I see here is a workshop database. And it is, look here, it is in the status pending. Let me make Cedric and make ourselves a bit smaller for the sake of the demo.
Oh no!
Yes.
Oh no!
I'll have to go
and
back
now we
to
are so small. Okay.
Here. That should make it easier for folks there to help, to follow through. You can now see, yes, we are very much smaller than we used to be. Yeah, who cares? We will go back to big when the practice is over. So you see the database is in pending state. And I want to ask you guys to please give me a thumbs up if you manage to create your database and get it in pending state. So while we wait for my and your database to get ready, we see if you manage to get to this point. Okay, I see a thumbs up.
Yeah, nice. Bridget Mo, you wink already.
So what are we doing? We are creating a database for, oh, see, mine has become active. Success.
Already?
My workshop
Wow, cool.
database has become active. Very good. Okay, so you are seeing, we are creating a database that is then, okay, I see thumbs ups. Great.
Nice.
So, oh,
yeah,
active
a lot
already.
of them
Very
are
good.
coming. That's cool. That's cool.
That's cool.
This database will last for the weeks to come.
Yes,
so,
yes.
You know, a lot of exercises to come with it.
Yeah, very good. And let me stress you, this is free, so you can not only use it today for the demo or for the practice, the exercises, not only use it for the next weeks in the workshop, but you can, and you are invited to, use it for your own experimentation, to build your own wonderful applications and do whatever you want. And if you manage to build something interesting, please let us know, because we are always very eager to know what you are doing with AstraDB. What kind of cool application you are creating. Okay, so I think we will give you your databases another minute or so to get to the ready state. And so let me stress you that you will have nothing to do except for using that database. So operations, creation of the database, management, the servers the database runs on, the nodes, it's all handled for you. So it's fully managed. You just create the DB and start using it and playing with it. Yeah, still pending, but no problem. It's probably going to become active in 1 minute or so.
Yeah, so you can ask why it take a few minutes to start. Well, when you start an instance, you start a full 3-node Cassandra cluster. So you need to start 3 machines and make them communicate to each other. So this is why it could take 2-3 minutes eventually.
Yeah. Yes, so no problem. Maybe let's yeah. So while we wait, I'll start switching to the README, so you see what is coming next. So we have a database, we have a key space in this database. That's all good. And we will start creating tables. So you have seen a create table statement in the slides by Cedric, and that looked quite much similar to what you would write in SQL for those familiar with that. And I always like to say one thing: don't be lulled into the sense that Cassandra is similar to our relational database just because the language it uses, it's similar to SQL. So CQL, it's the Cassandra query language, and it's specific to Cassandra. And yes, it looks like SQL, but the underlying database is much different. And many of the discussions we had today about data distribution and NoSQL and whatnot, I hope they have been shedding some light on this point. And probably next week with data modeling, this will become even clearer. So that being said, let's start and create some tables. Yes, you should be able to use Chine. You should be able to use any cloud provider and any region. In particular, you might want to choose a region that is closer to you for latency reasons. If you have any application in mind that might benefit from it, but that's really not so important maybe for today practice.
Yeah, and you don't need any, Google, AWS, or Azure account. That's really Astra platform that will create that for you, and it's free. I mean, you may have seen that there is 25 credit written somewhere. That represents about 40 million query a month.
Yes, let me show you.
And it's renew, refreshed every month. So even for small production and such, it's still free. So pretty cool, and you hopefully you will realize it's pretty powerful as well in the week to come.
So yes, this $25 is what you get for free every month to use. It's not what you have to pay, of course. And trust me, it's not easy to use them up in 1 month, especially if you experiment and play with the database. It's really impossible. Okay. So today's example is about a chat application called Cassandra, and basically there are two kinds of things that are users, and users write posts in rooms, chat rooms, such as there is here the example gardening, whatever. Okay, so there is a way to interact with Cassandra, and in this case with Astra database. And that is the CQL language and the CQL console we mentioned. That's absolutely not the only way. Indeed, if and when you will be writing code, you will be using drivers or you will be using other APIs, and you will probably not go by hand and write commands by hand in the console. But today, this is what we are going to do. So let me go to Astra again, and you see, I can click on my workshops database here. You see, this is my database that is become active. I click on it, and this is the detail of my workshops database here. So you see there are various tabs. By the way, there is a whole tab called Connect that will list several ways to connect with it. But today, we concentrate on this one, the CQL console. And what is this one? And I'm clicking on it here. The CQL console is a very handy console, just a text-based console that is there for me in the browser, you see, and it makes me able to type commands and hitting enter to execute them, exactly as any text-based console. So, and this will be today the main way we interact with AstraDB. Okay, so this is how you get to the console. You click on your database and then you go to this CQL console tab here. And this is where we will write a few commands to interact with the database. Okay, so first thing, we mentioned that, so I'm switching back and forth between the README and the console, and maybe let's keep this README URL again in the chat. That might be useful. So we mentioned that there are several we will be using a particular key space called Cassandra, and we will create tables within it. So first I want to see which are the key spaces that are there. So I might have I have my database and there are some key spaces maybe. So this is the command I have to use. This is the command I have to use to show them. So desk key spaces and then enter. So every CQL command should end with semicolon, as you see here, and desk key spaces is a shortened form of describe key spaces, and it will tell me what are the key spaces in this database. You see our Cassandra is here, and it's not the only one because, well, there are some other key spaces that are created for me, and they are system purpose, so that we are not concerned about them. But the important thing is that Cassandra is there. So from this point on, I will tell the CQL console, please focus on Cassandra, and every command I use, I will type. It's implied that it is working on Cassandra. To do that, I will just type use Cassandra. So when I type use Cassandra, you see that the prompt has changed and it tells me, yes, you are working on Cassandra. So every time we create a table, read some data, insert some data, if there is no explicit mention of any key space, that means I will be working on the Cassandra key space. That's handy. It makes commands a bit shorter. So let's go on. So we have been using Cassandra and now we are focusing on that key space, and we can finally create the table. So you see this in the README, you find this create table command. We are first creating a table for storing users of this chat application. Now, there is a question, SQL is generally case insensitive. I like to keep SQL keywords in uppercase, but that's just my choice. In general, SQL is not case sensitive, except when you use strangely capitalized names for tables and stuff, then you have to quote them. But please don't do that, because it will be more hassle than gain.
Yes.
So
you can make it case sensitive, but
you better
adding some
avoid
quotes for the table names and column names,
keep
please
it
don't do
simple.
that.
Yeah, keep it simple.
Yeah, use what we call snake case. So everything lowercase, and if you need multiple words, use underscore.
That is the easiest thing to use. By the way, that plays better with ORMs and object mappers, if I remember correctly, in almost all languages. So, okay. So this is how you create a table. This is a command you've seen in the in the slides already. So create table, table name, and then there is a series of column name and type. Column type. You see, email is a text, name is a text, and then there is this funny user ID of type UUID. Now, UUID is a special native data type available in Cassandra, and it is a uniquely generated ID. So it is a 128-bit, if I'm not mistaken, sequence that is guaranteed to be unique. Well, almost mathematically almost guaranteed to be unique, and it might be generated independently on several machines, and it guarantees not never to generate any collision. So we will be having a table called users with email, name, password, and well, this ID that we will use it to refer to users in other tables. Okay, so this is the most important part of this command, is this last line, primary key here. Because now we are saying that the primary key for the table is email. Not only that, but you see this double parenthesis here. We are also saying that email is not only the primary key, so related to uniqueness of the rows, but also is also the partition key. So we have been speaking about partitioning and distribution of the data quite a lot, and this will be very much important next week as well when speaking about data modeling. But the important thing is that now the columns that will be used to decide how to distribute rows in this user table is the column email. Okay, so enough with speaking. Let me copy this command and go and paste it here in the SQL console. Let me paste it. Create table, if not exist, email, and let me press enter. By the way, you see, you can also have a multi-line command in SQL console, no problem. Now let me press enter. You see, I'm back to the prompt. That means the command has implicitly succeeded. Otherwise, I would have gotten an error. Now, how do I know what tables are there? Well, if I write desk tables, short for describe tables, I will be told that there is a table called users. Wow, very good. So you should be able to be at this point also in your database. So if you desk tables, you should be able to see table users. I can also desk table users, which will tell me basically my own create table statement plus a bunch of settings for this table. Settings related to how Cassandra, or how Astra in this case, manages several internal settings, technical settings of how the table is distributed, and several maintenance tasks that happens behind the scenes. But anyway, the important thing is that if you describe this table, you see that it is the very same table we created. And this is how we created the table. So can you give me a thumbs up if you managed to create the table and see it in the desk tables? Yeah, very good. Yeah, I see you guys are doing great. Yes.
Yeah, good.
So this is how you create a table in CQL or in Cassandra and or AstraDB. Now, very good. Okay. So let's create another couple of tables. That's at this point it's not nothing so new. Look,
Yeah.
I'm creating tables to host to store the posts by those users. And you see the tables have fields such as user ID, which will refer to the other table of the users. And then we have post ID, room ID, you remember gardening or whatever, the post text. And if you look at this primary key, we have here a primary key that is two fields, user ID and post ID, but only user ID is used for the partitioning. Now, I don't want to dwell too much on this point because that's subject for next week, but in this table, partitioning is only by user ID, but I can have several rows with the same user ID and different post ID because unicity is the whole primary key. That means that my partitions will be made by several posts by the same. Every partition will be all posts by the same user because partition is by user, but every row will be a different post ID. You remember what Cedric has been saying about avoiding queries where you have to query several nodes, the so-called full cluster scans. Yeah, the point is that with this choice of partitioning, I will be able to get all posts by a given user without asking more than one node, which is good, which makes the query go fast. And indeed, this table is called posts by user. Now the funny part, and I will stop anticipating stuff now. The funny part is that I also want to get all posts for a given room. And for that, I will just create a second table with duplicated data, just arranged differently. Because you see, now the partitioning is by room. So if I want to get all posts in a given room, regardless of who wrote those, I will have to use this second table. So this is funny, and this is very much different than relational databases. We have no fear in duplicating data, just because we want to support different ways to read that. So let me just copy these two create table statements, and I'm creating two different tables, which will basically contain the same rows, just arranged differently. The rows, which will be one post in the chat application, every row one post. Okay, so you see, I have created three tables. And let me try these desk tables. You see, I have indeed three different tables in my key space, ready to get data. So, there we go. Yeah, so the reason why it's better to create two tables for the post, because they have to support two different ways to read data. Yeah, the explanation for that will be subject of next week, and there will be more to say about data modeling. I hope I just piqued your interest now. Can you give me a thumbs up if you managed to create all three tables, and if you are seeing them in your desk tables? Because this is what we really would like you to have hands-on practice of.
Yeah, nice.
Okay, great. Okay. Very good. Okay. So it's good. Most of you have been getting your own hands dirty. That's great. I think from this point on, I will just go ahead and do demo. And if you manage to follow along, you're very good. Otherwise, don't worry, because everything is spelled out in detail in this README, and you will be able to do it later. Because, by the way, this is part of the labs that you will have to do as completion to today's session before next week. So you will be ready for next week, right? But before, so maybe I can stop here before going on with the demo and give it back to Cedric for a little more explanations on what we just did.
Yeah, it will be quick.
Yeah.
Again, today we give you just a key to understand what is a table, how to put the first data in the database. Next week, we will give you all the theory to build some optimized table. How do you build a table? How do you build the primary keys and such? Here it just give you all the terms. So tables and partitions. So you just complete the first part of the end zone, which is create a database using Astra UI, creating some tables using SQL console. So the smallest piece of data you need to understand is a cell. Okay, is something very, very common, nothing special, but the data will be in a cell. Then with multiple cell, you get a row. Okay. Pretty also, pretty of use if you have already used SQL before. Okay. Then rows can be grouped into something called a partition. And this is where you remind all the beginning of the presentation, where partition is multiple rows having the same value for the partition key column. So here, if you look at my screen, the latest column is my partition key. So partition key is the name of the column, the department. They all have the same value, so they all are in the same partition. And as such, they are in the same node. So when you execute a query against Cassandra, you want to have in your where clause the value of the partition key. Why? Because Cassandra will know directly where all your data fit. And that's kind of a spoiler for next week, but you will build your table and schema based on your queries. Okay, so that's partition. And a table is a group of partition. Easy, right? Cell, row, partition, a group of partition. Now, just a couple of limits. If you want to know, in a cell, you cannot go up to 2 terabytes of data physical limit. And recommended size for a partition is less than 100,000 rows and less than 100 megabytes. But again, it will be covered in depth next week. So that's the vocabulary: cell, row, partition, tables, key space, and cluster. Now you have it all the levels. So I think, Stefano, you can go back just to demo mode to do a little bit more with partition and queries.
Yes.
Just create, read, update, delete.
Yes. So let me switch to us being small again to show more screen.
And yes,
this is how it goes.
End, we will come back and do the game to win some prizes.
Okay, so Yeah, so you've seen table creation. Now with the explanations by Cedric, it makes even more sense, I guess, now. We created tables, but of course, these tables are all set already, but they do not contain any piece of data yet. So we start doing CRUD operations. CRUD operations means create, read, update, and delete data from those tables. And these are the building blocks of any interaction with databases, right? So you always have to move data in and out and read and do stuff. Okay, so let's start by writing some data in those tables. Now, we start writing some rows in the user table, and we will just pretend there are 3 users in this chat server, and they are called 111, 555, and 999. So those will be the UUID of the users, and we will use this ID to as a reference also in the post table, as we saw before. And so we will start creating 3 rows in the users table representing the 3 users. So we have, you remember when we created the table, we had email, name, password, and user ID. So we want to create rows in this table, and this is the command we will run. So it will be insert into table name. Then you provide the list of columns you want to fill, followed by values and a corresponding list of the values per each column. So with this statement, we are inserting a row where email is otzi@mail.com, name is otzi1e, password is this very unguessable password, and the ID is all ones. So I broke down this command in multiple lines for easier reading. And let me paste it here in the console. So insert into table, column, 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 values, value, 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 value. And that's it. So you see, this command succeeded. And trust me, the users table now contains 1 row, which is very good. So we will quickly insert also users called Fred5e, which is all 5 in the UID, and Nina9e, which is all 9s. So let me, nothing new here, just we want to populate the table. So let me just paste these 2 commands. You see they succeeded. And probably now we have 3 rows in this users table, right? Now, let me write a few more things. So we want to make this chat application a bit realistic. So I will write some post also. Why can't we use Ctrl-V to paste? This really depends on the browser and the operating systems. In some browsers you can, in other you can't. So I want to play the safe route for you to be sure it works. So right-click and paste should always work, but you can try.
Exactly. It's at the browser level, sometimes at OS level, and it's for security reasons. So if you cannot do Ctrl-V, you just right-click and paste.
Okay. So let me write some rows. Let me insert some rows also in the post tables. And this is really similar. You see, there is an insert into table name. You remember post by users is one of the tables we created. And then user ID, post ID, room ID, text. So for example, user 111, you remember user called otzi1e, has created a post with a particular ID. In the room hiking, you see room ID hiking. And the text is some text he liked to write. Let me just stress one point. When we created the post by user, the post ID column is not of type UUID, but is of a very much related type, that is time UUID, which is, again, a unique identifier, but it also has the advantage of encoding a timestamp within the unique ID. That comes handy because it serves two purposes at once. One is the unicity of the values of the UUID, but also you can use this column to sort, for example, and you will have time-ordered items. So it's very handy. And well, let me paste this command here and run it. So I'm inserting into post by user. By the way, you see I can spell the name of the table without prepending a key space because I'm still using and working on the key space called Cassandra, so it's implied. That's what you saw before when we did use Cassandra. That's the advantage. Now there are a few more inserts. I will not show them in detail because they are really the same. It's just different posts on various chat rooms by different users in this pretend chat application. Now an interesting twist, because we have been writing into the table posts by user, but you remember we created two tables for the posts because there is post by users and posts by room, and they are supposed to contain a mirror copy one of each other. So the same post in one table should appear in the other table, just partitioned differently for different ways of retrieving the data. And the cool thing is that we have to do that on our side, which now means I have to copy paste a similar list of insert statements, but you see they are in post by room table. And this is cool because it means that when this will not be a sample session in the console anymore, but it will be something handled at the application level, your application will do the double writes, which might seem a burden, but actually it is an opportunity for optimizing the way you write data. But probably there will be more on that next week. I see Alex is eager to to start. So data modeling is a very cool topic, very interesting. Okay, so apparently we've been writing a lot of rows in all three tables. How can you be sure this happened? Well, you can do step 2, reading data. So you see, I could run a command like this, and again, this sounds very much like SQL. So select splat from table name. Let's see what happens. You see, what happens is that you get back all your rows. I'm reading from table post by user, and you see I have my results, user ID, post ID, room ID, and text. You see red is the color for the partition key, light blue is the color for the rest of the primary key. And you see rows come grouped by user ID. That's because partitioning is by user ID. So all ones are together, all fives are together. But this will not be a very good way to query the data. Because again, I'm trying to get all rows from all nodes. So I'm actually getting results from several partitions, which means, if you remember what about partitioning of the data, I'm actually speaking to all nodes in the cluster. And if this were a 2000 node cluster, this query would be very slow. And indeed, I would get a warning from the driver, from the CQL telling me, wait, are you sure you want to do that? And indeed, you should not do that. So this is more like a serious query you might want to run in production. You see, I'm selecting some columns from this table where user ID is a particular value. So you see, I'm asking for all posts by user 111. And this is the kind of query I want to see in production, because this will work fast. It will be having constant access time. Even if my cluster is 200,000 nodes, it will be fast because it will go directly to one node. And here I get all the posts by user 111 and only those. But see, they are mixed. the room is mixed because this is just how partitioning of this table works. Okay. So similar thing for the other room, for the other table. So if I want to get post by room, you see, if I just run a full cluster scan query, sorry, I copied instead of pasting. If you run a full cluster scan query, again, you get all posts, exactly as before, all posts. But now you see, I'm reading from the table partitioned by room. So the grouping is by room. You see now all running are here, all hiking are here. But again, this is not the kind of query I would like to see in production because it is potentially very slow and very inefficient. This is the kind of query I want to see for this table. So this table is partitioned by room. Indeed, a good query is the one where I have this where room ID equal something. And this query will give me all posts for the room hiking. You see? Okay, so these are, let's say, the basics of how you read data from tables and what is the right kind of query to run. More on that next week. You know that already by now. Okay, so these are the reads. Okay, we can skip this part and we can update data. So let's say we want to edit, so overwrite and modify the value stored in the table. Now, you want to change the value. What do you do? You should update an existing row. Now, well, here for reference, there is how the insert was done, how the table was built. But the point is that if I want to change the value, let's say, of the text in a particular post in a particular chat room, I have to do a write. But there are two ways to do that, indeed. But the important point is that due to the way Cassandra is structured, basically updates and inserts are the same statement. So you just write, because in general, writes in Cassandra do not perform a read before writing. So whether the row existed already or not, you are just writing. And if the row existed already, you are overwriting it. So how can you make sure you are overwriting it and not creating a new row? Well, that's where the primary key comes into play, because primary key guarantees unicity. So if you are writing a row that has the same primary key value as an existing row, it's implied that if it exists already, you are writing over it and replacing the values. And this is what I'm doing now, because you see post by users. Now I'll scroll up a bit. You see this, now maybe you can see it here. This Mount Gambo was easy exists already with user ID 111 and post ID AAA. Now I want to update the value in table post by user. So this is one way to do it. Update table, set field equal value, and then you put a where clause where user ID equal and post ID equal. And here I specify the whole primary key so that Cassandra basically knows which rows it has to replace. So let me run this statement. This is how I update a value. The important point is that if I want to replace a value in a row, I have to specify the primary key to be able to reach that value, to reach that row, to define it properly. But okay, so if you now read again, you will see that now I'm reading the row and you see that the text has changed. So all seem to work. There is a different way to replace and to update the value, which is, well, a consequence of the fact that inserts and updates are basically the same. So if I just run a new insert with the same primary key values as an existing row, as in this case, you see, this right is just a right as the first one we did, but it so happens that the rows existed already, and then automatically we have replaced it. And indeed, if you read the table again, the rows, the text has been replaced. By the way, I did it twice because you remember we had two different tables for the post. So I had to update the text in both tables, which was a good chance to show you two different ways to do it, with an explicit update statement and with just another insert. In both cases, I give the full primary key values, which means I'm just overwriting an existing row and not creating a new one. Okay, so the last point is how do you remove rows? So let's see. Let me show you how many posts are there by user 5. And this I do with this select. Select user 5, let me user ID equal 555. So there are two different posts. And for some reason, I want to delete this one. Again, the logic is very similar to inserting data because, so to replacing data. I want to delete a particular row, but then I absolutely have to provide the full primary key because otherwise what am I deleting? Okay, so this is the statement. In SQL, you run a delete from table and then you just specify the full primary key. Again, if you look at this whole code, I'm deleting manually twice from the two tables because the post has to disappear from post by users and post by room. And in the two cases, look at the different way I specify the primary key. I have to specify the primary key for that particular table I want to delete. So let me run again the two selects before, just as a way of proof. So you see these two posts are two different rows from different tables and they are there. Now I'm deleting from one and deleting from the other, again, providing the proper primary key to specify what I am deleting. Okay, should have executed. And now if I run these two selects, let's see, they are the same selects as before, and look. The posts have disappeared. So this, for us humans, is not there anymore in either table. Okay. So, okay, this is really just a sample of the four main operations you do with a database. After creating a table, you create data, so you write data, you read data, you update data, and you delete data. And this is how you do them in SQL. So this part, I just demoed it, but you are very much encouraged to go through it, to try the commands, and to read the explanations that are here that will give more context and will get you ready and primed for next week about the data modeling. I think with that, the demo part is over, Cedric, so I can switch back to directly to Menti, right?
Yeah, I think now it's time to play the game. We are almost on time.
So
We will finish on time. So,
okay, so let's give the code again. I hope you did not close your Menti connection because we are now.
Time, okay. Yeah, the code will show up.
Because it's now quiz time. So yeah, okay. So let's see if we can show the join screen again for you to jump on board, and maybe we can have some music.
Oh yeah, if you can have the music, that's even better.
Should not be too loud. Let's see. Okay, so do not forget that this time you better use Menti and not YouTube. Yeah, so the link should be. in the chat. It's me. The link is there. So menti.com. And then you insert the code you see now on screen.
Yeah.
Okay. So please jump on board. There will be a few questions, and this time, the faster you answer, the more chances you have to end up in the first 3 places and win some prizes.
Yeah,
So-
I was keeping up when the question will start. Please look at your phone or dedicated Menti, because the question will show there first, and the fastest you answer, the more points you get. So, and YouTube got 1-2 second delay. So to be sure to be as fast as possible, look closely at your Menti screen.
Yeah, absolutely. So I see you all guys are joining us. What do you think, Cedric? We wait a few more.
I don't want anybody to be frustrated. So let's say a couple of seconds. Yeah, let's.
So the numbers is rising.
To log in. I think you can move to next screen because it will be wait for player, right?
Okay. Oh. Okay, so we wait for players. Okay, so get ready because you have to answer correct and answer fast, and there will be questions about what we learned today. So I think we can start, and
yes,
you have to answer fast if you want to get more points. So how many master nodes does a Cassandra cluster need? At least 3 per cluster, or 3 per data center perhaps, enough to maintain consistency, or not a single one because Cassandra is decentralized. So let's see, a few seconds more to go. 2, 1, time's up. Let's see the answers. Oh, I see a lot of correct answers, not a single one. So Cassandra has no master, has no leader. Every node is equal to every other, so it's completely decentralized, and congratulations to those who got this right. Let's see.
Okay, who was the fastest?
Who was the fastest? I think we have a lot of very fast typers, and Jean is the fastest, but it's very close. So the game is still very open. Yeah. And let's move to next question then. Question number 2. Answer fast to get more points. In Cassandra, how is data being distributed? So all data is replicated to each server, or by partitions, range of partitions per node, or with address locators, or using postmail. So how would you do that? How would you distribute data in Cassandra? Probably by writing a nice letter with a stamp. Let's see, by partitions. Very good. So it is not true that all data is replicated to each server. Simply, well, because think about a very huge database. There will be no single machine able to host the whole of it. So it has to be split. And how it is split is by partitioning, as we discussed. Let's see. Fastest is Edson, who jumps to first position, but it's very closely followed by Jean, and Vishnu follows after. Okay, so there are still a few questions to go, so everything can happen. And let's go. Question number 3. Answer fast to get more points. Which replication factor is the recommended value? Let's see. It is 1.5, it is 3, it is 15, or it is a whopping 42. The answer to all questions in the universe. Let's see.
Yeah. But I don't think we put 42 as a valid question, as a valid answer, did we?
Well, I hope we did a good job at. Yeah, we did. Looks like we did. So, yeah, 3 is usually the correct value. Now it's very weird to think of 1.5 because you would have to, take a server and divide it in 2 halves. But anyway, 3 is the right answer. Unless there are very specific needs, 3 is usually the right choice. And let's see, the fastest was Bivan, who jumps a bit, but Edson, Jean, and Vishnu maintain the first 3 positions, so they are poised to claim their prizes. But let's see, there is still a few questions to go. Number 4, answer fast to get more points. What is AstroDB? It is a gateway to the stars. It is a local in-memory version of Cassandra. It is a database as a service built on Cassandra, or it is a development tool. A few seconds to go. Time's up. Let's see. It is a database as a service built on Cassandra. Well done. Well done. And that means, let's see, fastest Edson, who maintained first position, but Vishnu jumps to second position. Okay, so, but everyone else is very close. All the first 10 are very close, so there might still be surprises. And let's see question number 5. What happens? Answer fast to get more points. What is a primary key? It is the same as the partition key. It is the main house key. It does not apply to NoSQL databases. It is a unique identifier for a row, or it is a column in the partition key. Let's see, time's up. And uniquely identifies a row, correct. Now, it might be the same as the partition key in some cases and for some tables, and that's entirely a valid pattern, but it is not always the same. So logically, it's a different concept. And let's see, of the first positions, who managed to get, almost all of you got it right, and Vishnu fastest, but Edson maintained first position. But it's still a handful of points, so let's see with what is happening to Menti. Question number 6. There was a moment of a glitch, but it recovered, hopefully.
Too many people on Menti right now.
So what is the partition key instead? It is a consecutive number applied to each new record. It is a field in your table to partition your data. It is an optional table field for optional partitioning, or the key to partitioning this reality from the next. Whoa, let's see. It is a designated field in your table to partition your data. Very good. And it is not optional because it is really in the foundational idea of how Cassandra stores the data. So you cannot have table without partitioning in Cassandra. Okay. Let's see the results. And yeah, a bit of shuffling of data, but Jean jumps to second position. Edson maintained the first one, but I see there are some challengers down there. So question number 7, all marbles now. Let's see, last question. Executing a select query without the partition key is what? Is the recommended way to retrieve data. It is the right way if the data was inserted without a partition key, or it is a way to full cluster scan, or it is maybe illegal and punishable by law. Let's see. It is a way to full cluster scan. Yes, if you do a select without partition key, you potentially speak to all nodes, and that's not good in production. And tell you that there are I know some people who would really like to make it illegal. Yeah, totally illegal. Yes, I agree. Sometimes we joke about the SQL police catching you doing unallowed filtering, and that's really bad. But now we have a winner, and Edson maintains first position and is winning with Jean and Vishnu second and third. So congratulations, Edson, Jean and Vishnu. You will be awarded the prize, but congratulations you all for staying with us so far and learning so much. That's the real reward, as they say. But more to the point, to the winners, Edson, Jean and Vishnu, please take a screenshot of your winning Menti screen. I will not close the Menti now. I will just jump to Cedric, if that's okay. You take a screenshot. Sorry?
Yeah, you take the screenshot now. Stefano will move to just an open question like we use as a survey.
All right.
If we can improve anything. Winner sent a screenshot to Jack Fryer, seen on screen.
Yeah, we will show that again. So and just a quick survey. We want you to help us improve. So please let us know what did you like in this workshop and what we should improve for next time.
Yes.
Maybe I can leave this open.
Yes, exactly.
It's fun. See? Okay.
Yeah, so if you already win, if you have already won any swag from us, just say it to have as many people as possible win the swag, because we do not ship swag to the same people twice. Okay, so we are almost done for today. So just wrapping up now, a little bit more about homeworks, what we expect you to do over the week in between the two lives. You can use homeworks and you will see we do have a dedicated part on the README in GitHub. So 3 items. Item 1, complete the labs we did together today. So very easy. Stefano did the demo. You can always watch the replay. So complete the lab, easy. Just follow the instruction. 2, start your training, teaching, learning materials. For this week, we ask you to start DS201, which is a free online courses to get the Cassandra fundamentals. So a bit more deeper than these 2 hours. There you will see, I think, I don't know how many part of the courses, but please take it. You don't need to do the exercises. That's really all about the video, looking at the learning materials. If you want to do the exercises, go for it, but hold together with the exercises, it will take you about 4 hours. So, just for you to know, but, nothing preventing you to do it. For the courses and the exercises, we recommended using Docker for the exercises. Okay, so second, training. Third, fill the form, just validating your week, just to get a badge, okay? And, badge is always good to have. You can share it on LinkedIn and such. So 3 things, all detailed in the homework. Next week, we will cover the data model of, Cassandra and start talking about our app we will build together called the To-Do application. So, stay tuned. It will be same time next week. So 2 sessions, one on Wednesday. So it's 5 p.m. UTC on Wednesday, and on Thursday at 8 a.m. UTC. And if you live in India, the Thursday is 12:30 IST. Okay. Yes, DS201 recommended. That's kind of a something you need to do if you want to go for the certification. Certification, it's not easy. It's a certification, okay? So better need to come prepare, and DS201 is a good way to start. You will see over the week, you will have multiple courses to take. DS1 is just 201 is just the first. The purpose is really to be ready end of January to take the certification. And if you need any help, because the chat of YouTube will be closed very soon, we are on Discord. This is the link and the way to access it. We are more than 17,000 on not 100,000 yet, 17,000 on Discord, where you can see people chatting all week long, questioning about all kind of things. It's a funny community, so come and join us. Like and subscribe to YouTube if you enjoy the show. That's help us coming back every week. But nothing more to tell you today. Hope just you enjoy the show and hope to see you next week. Tell your friend it's not too late. Just the first session has just been made. We're just starting the 4 weeks. So anyone interested in learning would be interested in this content, I hope.
Yeah. So today is over, I think, Cedric.
Oh, yes, it is. I was thinking a final word. I don't know, but yeah, it was a pleasure to be with you today as usual. And hope to see you next week.
Thank you for staying with us. Hope you had fun. See you next time. And goodbye, everyone.
Cheers.
And as always, don't forget to click that subscribe button and ring that bell to get notifications for all of our future upcoming workshops.
In a being gifted with powers from the goddess of Cassandra, who grew those powers until she could multiply at will, move with limitless speed, and unmask hidden knowledge. With those powers, she was able to fully understand the connectedness of the world. What she saw was a world in need of understanding. From that day forward, she sought to bestow her powers on all who came into contact with her, empowering them to achieve wondrous feats.